So guys, let's come to the next question. It is from hydrology, that is from Darcy law. First I will recall the Darcy law. So according to Darcy law, the rate of flow, it is, can say, directly proportional to the hydraulic head and inversely proportional to the distance. So Q here is your discharge, or you can say rate of flow, which is unit of meter cube per day. Then H1 minus H2 are called as hydraulic head, simply you can say del H. Then A is your cross sectional area, then L is your length or distance between the aquifer. So it is in meter, it is in meter square. So it can be written like this: Q equal to KIA, where H1 minus H2 it is called as your head difference, or you can say hydraulic head, by L it will be I. It is called as your hydraulic gradient. And another thing here also, K is called hydraulic conductivity. It has unit of meter per day. Okay. Then Q equal to KIA. So you can replace this H1 minus H2 by L as hydraulic gradient, which is I, which doesn't have any unit. So discharge can also be calculated by this formula VA theta. So V is your, you can say interstitial velocity or linear velocity. So say interstitial velocity, or you can say velocity of the flow through the pore space. Then theta is called effective porosity, or you can say it is specific yield. Then A is as your cross sectional area. So we can equate these two equations, KIA equal to VA theta, where you will find KI equal to V theta. So remember this equation, so we'll use it in the next, this thing we used here and also used in the following numericals. Then another thing here, that is your small q. It is called as a specific discharge, or you can say Darcian velocity. So Q equal to Q by A. Q equal to Q by A. So as Q has a unit of meter cube per day, it has a unit of meter square. So Q has a unit of meter per day. It's called your Darcian velocity. Understood? So now we will use these equations in the formula, in the questions. So now let's solve some problem. So here, given a confined aquifer has a hydraulic conductivity of 25 meter per day. So K is given 25 meter per day. Okay. Then we have a hydraulic gradient. This I is given 0.004. Then if the effective porosity of the aquifer, that is given theta 0.20. In some question you will get it is 20%, but you have to take 0.20 for calculation. Then you have to calculate the true velocity. True velocity means the interstitial velocity or velocity within the pore space, that is V. So we know one equation Ki equal to V theta. So V equal to Ki by theta. So K is given 25 meter per day into I 0.004 divided by 0.20, which will be equal to, calculate, 0.041 0.1 0.5. It will be 0.5 meter per day. So the answer will be V will be 0.5 meter per day. Well, let's move to another problem. Groundwater flows through a sandstone aquifer with an average linear velocity. So linear velocity means V is given 1.5 meter per day. If the effective porosity means given theta, that is 0.30, and the cross sectional area, that is your A, it is given 600 meter square. Remind the daily groundwater discharge. You have to calculate theta. Sorry, you have to calculate Q. So Q by formula VA theta. So V is given 1.5 meter per day. Then A, it is given 600 meter square. Then it is given 0.30 theta. So it will be 270. It will be 270, then meter square meter into meter cube per day. So the answer will be 270 meter cube per day. Next, the two observation well drilled 300 meter apart in a confined aquifer show a piezometric head. So if you encounter any type of this like piezometric head or pressure head, that also indicate the hydraulic head or head difference. So piezometric heads are 72 meter and 60 meter. So now two observation well are 300 meter apart. That means we have L 300 meter. Okay. Now piezometric heads are, can take H1 72 meter and H2 60 meter. So given that the hydraulic conductivity is given, K is given 20 meter per day, and then the aquifer has a thickness of 15 meter and width of 100 meter. So thickness is given 15 meter, width is given 100 meter. So if you have thickness and width of the aquifer, then you can calculate the cross sectional area by multiplying thickness and width. So you can calculate the area by thickness into width. It will be 1500 meter square. Then we can apply the Darcy law, because it is asked about a water discharge between the two wells. So it will be Q equal to K H1 minus H2 A divided by L, or you can separately calculate H1 minus H2 by L as I, then you put that formula KIA. But we'll do this way. So K, it is given 20, it is meter per day, remember. Then H1 is given 72 minus 60 into A is given 1500 divided by L is given your 300. So answer will be in meter cube per day. So it will be 20 into 12 into 1500 by 300. It will be 1200 meter cube per day. Answer will be 1200 meter cube per day. See, these numericals are very easy, so you have to remember the formula. Then question also asked only in simple way, it given all the parameters, so you have to only put the parameter in the formula, and if you can calculate correctly, then your answer will be completely correct. Then another question, in an unconfined aquifer of width 200 meters, so it has given thickness 25 meter, width 200 meter, so area will be 5000 meter square. At the midpoint between two wells, if the water table drops 58 meter to 50 meter, that means your H1 will be 58, H2 will be 50. So we'll directly write down 8 meter. And a horizontal distance, that is your L, it is 400 meter. And the hydraulic conductivity, it is given 12 meter per day. The same question, you try to solve this. So it will be Q equal to K, then H1 minus H2 A divided by L. So remember, always try to write down the formula so that it will be easily memorized. So K is given 12 into H1 minus H2, it will be 8 into A is given, A we have calculated, this is 5000 divided by L, it is 400. L is 400. This is also 1200 meter cube per day. So you can calculate, it is also 1200 meter cube per day. So move to next question. Here we have, it is given specific discharge. So specific discharge, I have already told that specific discharge is small q. The specific discharge, it is small q, it is given 0.09 meter per day. So always remember, your capital Q by A is equal to small q. Okay. So the discharge is equal to specific discharge for unit cross sectional area. So the discharge will be equal to specific discharge or dash velocity for unit cross sectional area. That means if A is 1, then Q equal to capital Q equal to small q. So small q is given, Q equal to 0.9 meter per day. Then the effective porosity theta is given 0.30. So you have to calculate the average linear velocity, that means you have to calculate V in meter per day. So we know one formula, that is discharge equal to VA theta. So now you can write down Q by A equal to V theta, and Q by A is what? It is Q, will be V theta. So V will be your Q by theta. So Q is given 0.09 divided by 0.30. The unit will remain same as meter per day. It will be 0.3 meter per day. We come to next question. In a confined aquifer, groundwater flows at a rate of 180 meter cube per day. That means capital Q is given 180 meter cube per day. Okay. So through a cross sectional area of 900 meter square. So cross sectional area A is given 900 meter square. So under a hydraulic gradient of 0.003. So hydraulic gradient is given, that is I 0.003. So you have to calculate the hydraulic conductivity of the aquifer. You have to calculate K. So what is the formula? Q equal to KIA. So you have to calculate K. So it will be K equal to Q by IA. So Q is given 180. Remember, meter cube per day. Don't have to convert anything, all are in same unit. So A is 0.003 into, then sorry, I is 0.003 and A is your 900 meter square. So answer will be in meter per day. So it will be divided by, calculate, 2.7 meter per day. It will be 66.67 meter per day. So hydraulic conductivity will be 66.67 meter per day. So always try to pause the video and try to solve by yourself. Then you can see the answer. So next, a sandy aquifer has a hydrolytic conductivity of 35 meter per day. So K is given here 35 meter per day. Okay. Then if the piezometric head difference between the 2 points 250 meter apart is 10 meter, piezometric difference or you say pressure difference, they all are H1 minus H2. That means del H. Can I write down del H? Del H is 10 meter and L is your 250. And the cross sectional area it is given, A is given 500 meter square. And the cross sectional area it is given a 500 meter square. So we will calculate the ground water discharge, that is your Q. Same K, then we will take del H A divided by L. So K is given 35 into del H is your 10 into area is your 500 divided by L is your 250. It will be 700 meter cube per day. It will be 700 meter cube per day. Then comes another question. Groundwater flows through a porous medium with a Darcy flux. Darcy flux is also similar to your Darcian velocity or your you can say Darcian velocity or specific discharge. So Darcy flux it is your small q. It is 0.06 meter per day. Okay. Then if the effective porosity theta is given 0.15. So find the true velocity. You have to calculate the velocity. V will be q by theta 0.06 divided by 0.15. It will be meter per day. It will be 0.4 meter per day. This will be your answer. So these are all numerical that belongs to hydrology. Next we will move to structural geology question. That is your thickness. So thickness, first I will tell the formulas. So true thickness. Suppose a bed exposed on a horizontal ground, the ground doesn't have any slope. This will be the outer width, this will be the true thickness, this will be the depth of the beds, and T equal to W sine theta. So true thickness can be calculated by W sine theta. Any thickness that is measured perpendicular from the surface, take anything that is perpendicular from the surface, then it is called as vertical thickness. So vertical thickness equal to vertical thickness related like this, T equal to V cos theta with the true thickness. Then sometimes these beds are exposed on slopy surface like this. Always the ground surface is not horizontal. Sometimes they can expose on a mountain slope. Bed can expose on a mountain slope. In that case, the bed will exposing on a slopy surface. So in that case, how we will calculate the true thickness? There are two conditions: whether the bed and the ground slope are in same direction, or the bed and the ground slope are in different direction. Suppose this is the bed, it is dipping in this direction, and this is the ground surface also dipping in the same direction. In that case, you remember T can be calculated as W sine theta minus I. So theta, you know, this is the deep of the bed, and I, you know, it is the slope of the ground, or you can also say deep of the ground, slope of the ground. And this is condition where both are dipping in the same direction. If both are dipping in the opposite direction, then T will be W sine theta plus I. This is for opposite dip. This is for same dip. Same dip means same direction we are talking. Same dip. So now we'll use these formulas and try to calculate or try to solve all these problems. So let's move to first problem, that is a sedimentary bed of uniform thickness crops out on a hillside inclined at 25 degree to the horizontal. That means the hillside has an inclination, that is your slope, that is your 25. The bed dips 40 degree in the same direction. So bed dips 40 degree means theta is equal to 40 degree, and both are dipping in the same direction. Both are dipping in the same direction. We'll take this as a symbol showing they are dipping in the same direction. So they are dipping in the same direction. If the outcrop width measure along the slope, the outcrop width along slope, that is W, it is 120 meter. So how we will calculate the true thickness? So simple, put the formula and we will get the answer. P equal to W sine. So they are dipping in the same direction. So it will be theta minus I. So 120 meter, then sine theta minus I, 40 minus 25, it will be 15. So we use the calculator. 20 into so T will be, it is 31.058. Okay. Then in question is always asked, you have to round up to 2 decimal or round up to 1 decimal. So if you round up it up to 2 decimal, it will be 31.06. Okay. If you round up it into 1 decimal, it will be 31.1. So if any, you have to round up to 2 decimal means you have to look for the third place. If that third place it is 5, or if it is 5 or more than 5, then the second place will increase by 1. Similarly, here it is 8, so second place will increase by 1. And if you have to round up to 1 decimal, the second place it is 5, so it is 5. If it is 5 or more than 5, then it will be increased by 1. So it will be 31.1. So this is round up to 2 decimal, this is round up to 1 decimal.